Welcome, everybody. Mr. Chairman, this evening I would like to give you a short presentation about our work, what we carried out with using artificial intelligence method. And it's a little bit different because it's not dealing with the structural integrity, but the evaluation by NDT. So the NDT is a very deep part of this structural integrity evaluation as well. But usually we have difficulties when we would like to do non-destructive testing, especially with X-ray imaging, that we would like to get to determine the flows. We have to determine whether the inspection of the component of the infrastructure is acceptable for continuous safe operation, and or we have to give advice to the safe general public and environment. So what we need is, if we talk about NDT for digitization, that we have to usually increase the inspection safety and reliability, what is not a obvious way to do because it's quite difficult, because it depends on the human resources and human capacities. And we have to reduce the inspection time because we usually have a lot of images. If we would like to build, for instance, a power plant, and we have a lot of wells, we have a lot of pipes, so it takes a lot of time. We have to carry out the inspections, and we have to allow accessibility for non-accessible areas, and we have to somehow to save the human operators' health in some kind of environments, in chemical plants or in nuclear plants as well. So what is behind our study and our research, what we carried out? We have a current radio flow detection, and that is mainly based on manual evaluation. Nowadays, what is quite significant, it depends on the human itself, and very time consuming. And if we look the human resource market, it's very difficult to find any person who is a certificated person to carry out evaluation. So the purpose of the goal, what we carried out, to develop a complex image analysis and evaluation application for according to the standard for analysis the metal and their alloys, and which aim to evaluate the image flow result from internal and external sources, and comprehensive as possible based on EI technology. So what the basis of this story, that we have a laboratory management system, information management system, that where we can find the basis information about the test, mainly NDT test, X-ray imaging test, the X-ray images uploaded in the management system. So we have a providing database, administration, and management system. And we have application clients, and we have to support the clients based on EI technology to support the evaluation of the X-ray images evaluation mainly. What we had to concentrate on, what the focus point was the connection to the information management system. We had very important point that we have to apply the standardized evaluation. So standard contains very deeply and very precisely explained how to evaluate X-ray film. And based on that, developing a framework of the application and registration of material test. And we have to sometimes edit. We have an editor module because the EI can do kind of preliminary work or pre-evaluation phase. After that, you need a supervisor. The standard requires that all evaluation needs a human supervising of the results, and that the EI cannot supply the final result, just a pre-analysis. So always a human supervisor is needed and by the end of the story. So after that, the EI module was developed, and we have a EI image analysis module. So this shows somehow the flow chart of the if you have image. It goes to the EI module, detects the imperfection of list, the binary EI imperfection or no, and after that the classification and the parameters was given, and after that we can have a result, and after that we can evaluate based on the standard, and then so on. So, and here we can have a manual correction of the result, and that we can use to train the already ready AI module as well, so that it continuously can develop. So how it looks like, more or less visible, but recently we applied 3 evaluation standard. Is an entity standard that both all of them is based on the ISO standard, and contains how to evaluate the entity test on certain application in steel, aluminum alloys, and in case of weld, steel weld for fuse, and how we have to evaluate the imperfections. So what we usually use is a very, I don't want to go deeply because maybe some of you know, and the others maybe not very deeply interested in that. Usually very interested in approximately 10 or 15 years ago, the unit architecture was introduced in medical science, mainly for evaluating images of the cells and the microscopy evaluation, especially for laboratory cancer diagnostics and such kind of issues to determine what kind of cells you can see on the. So this comes from the medical science, mainly this unit. What is has a decoding and encoding start phase, and this can give a very this is very useful, and nowadays this is a very basic application for the image recognition, the AI technique, and so it's just described here. So, but what I did first is a binary classification. We have to find the imperfections on radiograph film, X-ray film, and after that, if we have to define the spots, what is the imperfections, and after that we have to classify what we found out. So in this case, we need the image recognition, and that's why we use the ResNet, what is a deep learning methodology architecture, and very good for the classification. And after that, for the training, this is a cross entropy loss method was used to measure the loss of the information. And this is and some kind of very common used ADAM optimization algorithm was used. So how it looks like? So that first, in case of binary classification, we have this kind of labeled image film. It means that for the training, for the trainee to the AI, we need a lot of labeled image. This is very time-consuming and very hard work that we had to ask several colleagues to label the available X-ray films to be able to teach the AI. After that, we can have a binary mask. It's quite simple. And after that, the AI can also detect this kind of result from based on the binary classification. Also, you can see it here as well. In other case, another labeled image can be seen here. This was used as a binary mask. And after that, the AI result can see here. I guess quite good correlation can be seen. Of course, there are some differences. So you can see the width of this a little bit different. Size can be a little bit different, but more or less acceptable. So, well, more or less visible also. So we have a AI editor window for evaluating image. And after that, if we have the original film, or AI technology can evaluate the result. As first, the image can find the imperfections, as I mentioned before. And after that, the classification can be carried out. And you can see, for instance, the codes of the different imperfections, defects, microcaches, gas port, clusters, and so on, what you can find usually in a well. So this is comes from the standard, and if you can set a color for it, you can see that what we can find and how can we find in different cases. So it's a quite powerful tool for us. As I mentioned, we have the application for it, and if you can see, so if you upload a picture, image, X-ray image, that after that first evaluation can be carried out by the EI, and after that you can have the first evaluation result as it is shown in the table, more or less visible. But this result can be automatically uploaded back to the laboratory information system, and the result can be modified and overwritten based since it's always a correction is needed, and it needs to improve the AI itself. Also, very important that, as I mentioned, the supervising and the manual correction is very important to carry out. So, especially in the teaching phase, that when we have to teach your EI, it's very important to correct the EI first result, and after that you can upload it back, and then after that it can be used for further improving the evaluation. So, and the final result of the evaluation shows that what is permitted or acceptable or not acceptable. The more or less red is not acceptable. This should be green, and it's not. It's an acceptable result. So, and based on the size and based on the positions, for instance, we can find this defect is here, and in a certain level of it is acceptable, but if you look at the other levels of that, it's not can be not acceptable for based on the standard evaluation. So I just skip this video because it shows just what I present. Just what I would like to show that maybe I go back because maybe it's more visible in here than the picture that I put into the slides, because somehow the slides is not really visible. So so first we have to we need the project was uploading, and after that we have the free X-ray film here, and after the AI based imperfection evaluation carried out. So this is the first window that you get, and this is the list based on ISO, for instance, this standard, and it goes on, and finally we can find some imperfections and detect based on the area, diameter, length, width, and so on. So this is can be carried out quite well. So since I don't want to run out in the time, so this is how it was built up. And though it seems that it's a quite robust tool, what we have can evaluate X-ray films. Recently, only based on 3 standards, and based on manual correction, we can improve the efficiency of the AI recognition of the imperfection and the flows and indications. And as a conclusion, so we can say this is a continuous system learning solution. So what we corrected manually is used in later evaluation. And well, what was the goal? I guess we were successfully satisfied and completed. So the current flow is on the data collected during the produce of the elevation X-ray images. It's quite fast, efficient, and automated image analysis result Also, always we need an expert to supervise it. So I guess it's quite useful, and we would like to continue such kind of work to improve our application for another standard, and even we would like to extend this applicability for other applications as well. Thank you for the discussion.